Okay, so remember in the last video where I explained all the prior to the singularity, and I explained it in several videos. Now that coincides with thermodynamics. And this state right here, when it's an absolute zero, this would be the third law of thermodynamics. Basically, it goes from the coldest, absolute zero, and it starts to spring up, going from cold to warm to hot. That's the heaviest and densest and hottest at the singularity. The singularity inflates and dies, becomes the universe. Now it's warm again, and then it's going to go back to cold. Now, remember I explained that spring shares the same temperatures with fall. And this is a nexus because this is a neutral point. This is a neutral zone that both of them share. Temperatures are rising in this one, temperatures are falling in this one. And that's how the universe was when it reached 2.7 Kelvin before it got to the singularity, which was the hottest, and then it cooled to 2.7 Kelvin where it's at now, which would be the fall. Now, this is a cyclical motion because even our seasons will do this, because it's from winter, spring, summer, fall, and then it goes winter, with the eclipses doing the same thing because of this cyclical process. It's cyclical, a cycle, a circle, or a wheel in the sky that keeps on turning, red shift and blue shift. It goes from night, or the new moon, to dawn, the third quarter, the full moon, to noon, and then when the light is moving out, it moves to dusk, which would be the first quarter before it reaches a new moon. So our days, the moon cycle, and the temperatures of the universe, and our seasons all do the exact same thing. It just seems like this is the part that the scientists are actually missing prior to the singularity. You might say 2 seasons before the singularity. They have the singularity, which is summer, and then fall. Fall is now, the current observable universe, and the singularity when everything began. But there's nothing prior to that they have none of it. Mainly because they throw out the first, second, and third laws of thermodynamics, and then don't even look into how the fourth one would actually apply, which is Osinger's reciprocal relations. Meaning there's a point where it gets into absolute zero and equilibrium where it just can't work in reverse. But that's not true because of the conservation of energy. And energy and mass go hand in hand, so wherever you have energy, as a whole, in space you still have mass. Even though it's not in a massive state, it's energy. It's liberated energy, you might say, from when it was in a lower state called matter. And then the matter, or mass, is weight. And energy equals weight, and weight equals gravity. So gravity is always conserved, which is the weight of the universe. This means when everything reaches equilibrium, because it has weight, because the first law is in order, the fourth law has a paradox in it. Basically, it is in a state of equilibrium, meaning that typically, if you knock a glass off on the ground and it breaks and it goes into that ground state and all the things or the pieces are just spaced far apart and in ground state, that it's not going to just come back together and refix itself on the table that got knocked off of. But the main reason is because it's on the ground and there's resistance on the ground and it has weight and gravity and friction because of the ground. But in free floating space, there is no friction. And in this state here, in absolute zero, there would be zero viscosity either. So in this aspect, because it has weight and because of conservation of energy, it has no choice but to recollapse.